You're about to watch a simple demonstration on the litmus test for acid and base. Secondly, you are going to see detailed explanation on the topic acids and bases. Then lastly, we are going to see simple calculation involving pH scale. Hello and welcome to this special numerical class. Today we are going to be seeing acids and bases. The truth is that most students define acids and bases based on the color that is observed when you test them with litmus paper. But then acids and bases are more than the observation of color. Okay, let us single acids out and study it in detail. Acids. According to Bronsted-Lowry, they defined acids as any substance that when you dissolve in water produces a proton, which is in form of hydrogen ion or hydrozonium ion. Now these two guys, Bronsted-Lowry says that acids produces what? Acid produces hydrogen ion or hydrozonium ion. This is how we write hydrozonium ion. This is just an extra proton in water. Okay, so for some textbooks you will be seeing hydrozonium ion, while we should know that it is the same thing as hydrogen ion. Now they said it is what? Any substance that in aqueous solution produces a proton. Okay, this proton is what we are going to be calling hydrogen ion in this definition. All right, now another person defined acid as electron pair acceptors, and this is according to Lewis. Lewis' definition is still valid today because we know that acids are what? Electron pair acceptors. Then for Bronsted-Lowry, their own definition is suggesting that acids are proton donors. See, it's like words and opposites. This guy said acids are proton donors, while this guy said that acids are electron pair acceptors. Now this is just a brief discussion on the definition of acids. Okay, so acids have general characteristics in terms of taste. Acids have sour taste, especially when they are in dilute form. You are not advised to test concentrated acid, especially the ones in your lab, because they are not meant for us to test. Okay, but you can notice the taste in natural fruits like lemon, like the one that we Igbos call udara, and pineapple, and anything that can sour, that can, it's as if the thing is slapping you when you taste it. Okay, it indicates the presence of acid. Okay, so in biochemistry we will understand that these acids, especially the organic acids, are what? Important in our body system, but to some extent this acid may become dangerous. Okay, so let us go further to look at the different types of acids. Okay, we'll be looking at acids based on one, their ionization in water. This is where we will have strong acids and what? Weak acids. Remember that ionization is talking about the dissociation into ions. Okay, so water is H2O. It means that when you hydrolyze water itself, you will be having hydrogen ion and hydroxyl ion. Now, when you introduce a substance in water and it ionizes completely, it dissociates the compound that is supposed to become the acid completely. It means that that substance is what? A strong acid. So by definition, strong acids are acids that ionize completely or perfectly in water. Then that of weak acids are acids that ionize partially in water. There is incomplete ionization of such substance in water. Examples of strong acids are these three major acids that we know. First one is HCl, second one is HNO3, third one is H2SO4. This is hydrochloric acid, this is trioxonitrate 5 acid, and this is tetraoxosulfate 6 acid. Now, notice that while I'm pronouncing the IUPAC nomenclature, that I avoid mentioning hydrogen, because when you mention hydrogen, you are referring to this substance as a gas. As a gas. Meanwhile, a gas is yet not an acid until you have dissolved it in water and it splits and releases the hydrogen ion according to Bronsted-Lowry's definition. Okay, so you will avoid mentioning hydrogen. You rather mention the rest and then end up calling it an acid. It now indicates that the substance is in aqueous solution. So this aqueous solution signifies that this substance has been dissolved in water. We are not writing liquid here. Liquid is a state of matter. In chemistry, we indicate every substance that is in liquid form as aqueous. It is only water that we indicate as liquid when you are talking about the chemical nature. Okay, so this is hydrochloric acid, this is trioxonitrate 5 acid because of the presence of the hydrogen. Then this is tetraoxosulfate 6 acid. Okay, these are strong acids. Examples of weak acids, you can have the rest. You can have citric acid, the ones that you get from your oranges, from your lime, your lemon, etc. Citric acid. You can have your acetic acid. Acetic acid, this is the one that we commonly call ethanol. Okay, that is CH3COOH. That is it. Then we have mentioned them, there are a lot. We can have this, which is your phosphoric acid. Okay, then apart from this category, which is falling under ionization in water, we can still have other types of acids. Okay, let us see based on the replaceable or ionizable hydrogen ion. Let us bring them out. The next category is based on the replaceable hydrogen ion. Now, some of these acids that we have, some of them can ionize in water and then retain some of the hydrogen they contain originally. Some of them have the potential to release all their hydrogen ions. Okay, so the ones that release one is what we call the monoprotic acids. Example is HCl. This will ionize to give off all the hydrogen it has. Okay, then the next one is diprotic. Now this one is H2SO4. This one contains 2 replaceable hydrogen ions. Okay, so it means diprotic, 2 protons. Okay, this one is monoprotic, 1 proton, which is 1 replaceable hydrogen is available to ionize. Then this means 2 available hydrogen ions are available for ionization. Then the last one is what? Triprotic. Good example of this one is your phosphoric acid. All right, so these are types of acids based on the number of replaceable hydrogen ions. So this is it. Now the next one is based on whether they are organic or inorganic. These organic acids are the ones that are made up of carbons. Okay, you have carbon in this compound. Then inorganic or mineral acids are the other ones that are not made up of hydrocarbons. Okay, so it is very simple. When you see them, you notice them very, very easily. So if there are other types of acid based on, okay, we can still have acid based on how you prepare it. Okay, so you based on their chemical nature, on chemical let's say nature or composition I can tell you that we have the ones that are binary acids, which are just made up of 2 elements chemically combined together. Example is HCl, just hydrogen and chlorine. Then we can have oxy acids. These oxy acids are the ones that you hear oxo, trioxo, tetraoxo. These are under oxy acid. Example is H2SO4. Example is NHNaO3. You hear tetraoxo, trioxo. They are under oxy acids. Okay, so this is just a general view of what acid is. Now when you want to test for acid, we can test acid using litmus paper. When you dip your litmus paper, your blue litmus paper, in a liquid substance and the color changes to red, it indicates the presence of acid. So it turns blue litmus paper red. I'll show you the practical example and you get to know this thing in real life. So we are going to be looking at bases. I believe this is a summary of what you should know about acid. Okay, then another test for acid is when you test acid using a pH scale. The pH scale is numbered from 0 to 14, where 7 is the middle. Okay, so going this direction, it increases the pH value of that substance increases in acidity. Then when you are going towards this other direction, the pH value will be increasing in alkalinity. This is talking about how much of acid. This is talking about how much of base, or the strength of the acid and the strength of the base. Okay, now notice that from 1 to 6 are acidic, then from 8 to 14 are what? Basic. Are you getting it? Now when you are going towards this direction, 6 is less acidic than 5. It means that 5 is more acidic than 6. Then when you keep on going down here, it means that 4 is more acidic than what? 6. So while going towards this direction, you are increasing in acidity. Then for this other side, 8 and 9 is more alkaline than what? 8. Then when you are using it in terms of acid, it means that this 8 is more acidic than 9. Now, but for secondary school standard, you have to limit your knowledge of acidity to this side. Okay, where 7 is what? Indicating neutrality. Okay, example of a substance that is on this scale is water. Water is neutral. So a lot of other substances are neutral. Okay, but let us limit what we know for now to water. The same thing happens to litmus test. A lot of substances are neutral to litmus paper. Okay, but let us limit our knowledge for now for what we should know for acid. Okay, now let us briefly discuss bases. Bases are substances that neutralize acid to form salt and water. This is called neutralization reaction. Okay, acid plus base will give you what? Salt and what? Water only. And water. Okay, so a base is any substance that neutralizes acid to form what? Salt and water only. So in other words, this base can potentially reduce the ability of an acid to produce hydrogen ion when they mix together in a chemical reaction. Okay, hence, since we know acid as what? The donor of a proton, this one will be donating or releasing hydroxyl ion. Remember that this is what we ionize to form what? This water. Okay, so we should know base for releasing hydroxyl ion, and then we should know acid for what? Releasing hydrogen ion. Okay, so the presence of hydrogen ion indicates acid, the presence of hydroxyl ion indicates base. But then there is more to this. You cannot limit your definition to the presence of hydroxyl ion. Now this will lead us to other ways of seeing bases. Okay, let me show you something. Bases cannot be limited to presence of hydroxyl ion because there are 3 things that make up base. One is a metallic oxide or metal oxide. A metal oxide is a base. The next one is a hydroxide. hydroxide, in which case I have mentioned it here, the presence of hydroxyl ion indicates base. So hydroxide is what? A base. And the last one is carbonate. This is where students may find it difficult to understand, but I will break it down in this class. Metal oxide, example is sodium oxide. Sodium oxide. Okay, sodium oxide is a base. If you dissolve sodium oxide in water, it will produce sodium hydroxide, and this is what students will always know as base. Are you getting it? So it does not limit the definition of base to what produces hydroxyl ion. However, you can also tell that a base is any substance that when you dissolve in water produces hydroxyl ion. That is true, but then it is not a must that you know base when they are in aqueous solution. Okay, like sodium oxide is not an aqueous substance, it could be just a solid. Okay, but then it is a base. Any day it dissolves in water, it also produces this other type of base, but we have a name for this. What we call it is alkalis. Alkalis. Alkalis is any base that can dissolve in water. For instance, this can dissolve in water. This can also be dissolved in water. But this is not an alkalis, but this is an alkalis because this is the one in aqueous solution, while this is in solid state. Are you getting it? So this is an alkalis. Any substance that has been dissolved in water to produce hydroxyl ion is an alkalis. First, it is a base, and then it is an alkalis because it was able to dissolve in water. Okay, but any other substance that has not been dissolved in water to form hydroxyl ion or cannot even dissolve in water are just bases, but they are not alkalis. Until they are able to dissolve in water, then you can be able to call them alkalis. Then these are other examples of hydroxide apart from sodium hydroxide that I've written here is calcium hydroxide. Okay, so this is other type of base, carbonate. Example is sodium carbonate. Okay, sodium carbonate. This is also a base, but you will only call it base when you have been able to dissolve it in water so that it will be able to form something like this, sodium hydroxide. It means that you can use sodium carbonate as a base during titration. This is normally a salt. Yes, it is a neutral salt, a normal salt, it is a normal salt, but then we can use it as a base during titration because when it dissolves in water, it produces the real base that we know, which is sodium hydroxide. Okay, so these are the three things that form what? Base. Base. So one is that you should take home that any substance that can produce hydroxyl ion is a base. This can produce hydroxyl ion, especially when you dissolve it in water and you have something like this. Even if you have compounds like calcium oxide that can barely dissolve in water, it may not even be able to dissolve well in water, but then it will dissolve in water too. Some of it will dissolve to form calcium hydroxide. Okay, so this substance is still a base, but until then, the next one is hydroxide, the ones that you already know as base. Then carbonates. Many people may not be able to put this in as a category under base. Okay, but then when it dissolves in water, it could still form hydroxide, making it what? Basic. Okay, so under test of base, let us see litmus test for base. litmus test. Bases turns what? Red litmus paper blue. This is opposite of what we know for tests for acid using litmus paper. So while acid turns blue litmus paper red, bases turn red litmus paper blue. Red is indicating danger. So when a blue litmus paper is turned red, it means danger, indicating acid. Then when a red litmus paper turns blue, when you test it in a substance, it indicates the presence of base. It doesn't mean that bases are not dangerous. As a matter of fact, the both are corrosive, but they have different ways of acting as corrosive substance, okay, of corroding substance. Then under the pH, like I have drawn before, this is 7 for neutral compounds that are neutral to pH. Example is water. Then when a substance is between 8 and 14, that substance is said to be alkaline. It tests for alkalinity. So the strength is going towards this direction. It means that if you have a substance that is, let's say 2 substances, one is here and one is here, it means that the one that has the 10 value is more alkaline than the one that has what? The 8 value. So that is that for what? pH. We will go further to look at the properties of bases. Okay, bases, for instance, have bitter taste. It has other ways of what? Reacting to other liquid indicators. For instance, bases turns methyl orange turns it what? Yellow, like the sun. When you drop methyl orange indicator, maybe 2 drops of methyl orange indicator in your base during titration, the color changes to what is like a sun, like the color of the sun. That is yellow. But originally the methyl orange is orange in color, but what you are seeing is what? Yellow. Then it turns let's say phenolphthalein pink. When you put 2 drops or 3 drops of phenolphthalein, which is a colorless liquid, in a base, you will notice a pink color. This is other ways of testing for base using what? Liquid indicators. Okay, that is that. So let us briefly see calculation, one single calculation on pH scale. All right, so let us say calculate the pH of 0.001. okay, let's make it 0.001 molar solution of HCl. If you are given a simple question like this, the question is understanding that pH is the hydrogen concentration of what? Acid. Okay, this is an acid. Okay, so but in pH scale, we do not only find that of acid, we also understand that we have what that of what base, which we indicate as what POH, which is equal to what the both is what 14, meaning that this one contributes 7, this one contributes 7, and it gives you what 14. So ionically we can bring it to something like we introduce a character like this. This character will be representing what we call what concentration. So you will have something like the hydrogen concentration plus what hydroxyl concentration will give you what 10 raised to power what minus what 14. Now this will help us, 10 raised to power 14. This will help us to what calculate the hydrogen concentration of an acid or hydroxyl concentration of a base. Now in this question we just have to use 1, which is what hydrogen concentration of what this acid. Okay, so by definition pH is equal to negative logarithm in base 10 of what hydrogen concentration of an acid. This is another way of defining what acid, because this pH is talking about the presence of hydrogen ion. So we can define acid as the negative logarithm in base 10 of hydrogen what ion. So in this case we have that pH is equal to minus log in base 10. This hydrogen concentration is what you are giving here as what 0.001. Are you getting it? So we can raise this thing to standard form. Then we will have minus this. We have 10 raised to power what minus 3. This is the same thing as what you have here. Okay, 0.001 is the same thing as 1 times 10 raised to power what minus 3. Now we can then remove this character. Now according to a law in logarithm, you can bring this particular 3 to this place. You have something like this: pH equal to minus, we are bringing the minus 3 here, are you following? Then log what 10. Okay, I just moved this raised to power to this other side. It is a law in logarithm. So we have pH to be equal to minus is what plus. So we have plus 3 log what 10. There is another law in logarithm that says that log 10 is equal to 1. It means that pH is equal to 3 times 1, and then pH is equal to what 3. So this is your answer. This is also the same pattern you use to solve for POH, for hydroxyl concentration of a base. Alright, so this is the same pattern, it works for everything. So when you have this, to know that of POH, for any substance that will neutralize this particular concentration of this acid, it will be given as what 3 plus what the unknown. For that would be, let's say it is the POH, for it to be equal to 0. For it to achieve neutralization, complete neutralization, it means that this will go over to this other side to give you POH equal to 14 minus what 3. So POH will be equal to what 11. It means that the value of the base that will completely neutralize this concentration of this acid HCl will be equal to what 11. So this is just a simple calculation under the pH scale. Thank you for watching this wonderful video. I hope you enjoyed the video. I hope you got something. If this is your first time of watching our videos, please kindly subscribe to our YouTube channel and follow us on all social media platforms.